Okay, welcome back to CCPM setup part 2. In this step, what we're going to do is we're going to work our way up. We've already got our servo centered as in the previous part, and we're going to work our way up through the head, getting the swash plate level, getting it the right distance, getting the right travels, and all the right links and arms set up. Something you'll notice that I didn't show in the previous step is I've trimmed my servo arms, the remaining piece off, and the reason that is if you look, full negative and cyclic can put that arm into the gear. Okay, so if you left that piece on there, it's going to be clicking on the gear there. Also, you'll notice this is why I showed this in servo installation, is we put this servo, these frames you can put this servo on the high side or on the low side. I put this servo on the low side, so if this arm does get into the gear, it's just going to click off as part of the direction of rotation of the main gear. If we had this lower servo on the other side, if this arm went into the gear, it would come into the oncoming portion of the gear, which could be disastrous. Okay, so the first thing we want to look at is where our swash is in relation to the arms. So as you see here, at full negative, back on the throttle stick, the swash plate's far too low here, and it will interact with the frames when you give cyclic. So our arms are too short. Now, by the way, all the arms throughout the head and these arms were set the lengths per the manual. Okay, it's a good starting point, but we're going to wind up changing all these lengths. The other thing you'll notice is when I go full positive, my washout block is not coming all the way up to the head. So I can zoom in and show that. Pardon a minute there. The washout block is not coming all the way up and close to the head. We want to adjust these links to move the swash plate up. We saw it was too low at full negative. To move the swash plate up until this washout block and that bushing just almost touches the head. That'll give us our full range of movement without any problems with the swash plate interacting down here on negative. So I'm going to go ahead and increase these links. I'm going to set them all so the swash plate's level, and I'll show that when I'm done. So I'm going to go ahead and increase the lengths of these links so that washout block is almost touching the head. Okay, and when I'm done with that, I'll come back and we'll talk more about adjusting the links. Okay, we're back, and what I've done is I've lengthened these links and got them all so that the swash plate was level. We're only a little close right now because we're still going to mess around with these links, and I'll explain why. Now that we've got this, here's full negative, you can see we don't have any issues now with the swash interacting with the collar down here at full negative. And at full positive, we can see our washout block is just barely coming to the head. The servos aren't buzzing, and there's just a hair of a gap where the bushing meets the head. Okay, but we've got a problem. And this is why all these links interact with everything as you change or shorten them. If you notice, I'm now at center throttle stick. And you'll notice the washout arms are not level with each other. This ball should be in line with this screw. And the reason that is because this link here is too long. It's pushing this arm down, and it's not allowing these arms to be level. Now, when I change this and shorten these, it's going to move the washout block up, and I'm going to start striking the head. And one of the things I noticed as I was lengthening these links is I'm way out on the threads here, kind of unsafe. So what will happen is when I shorten these to get these arms together, it's going to move the washout block up, it's going to start hitting the head, and I'm going to have to bring my swash down a little bit. So this is all part of this step, is playing back and forth with these links and this link up to the seesaw, and getting at half stick, the swash plate level at half stick, these arms level with each other, and so that at full negative I'm not having an interaction down here with the collar, and at full positive the washout block is not hitting the head, binding the servos. Okay, so this is a back and forth operation. So I'm going to go ahead, I'm going to shorten these links, then that's going to bring the washout block up, and I'm going to then shorten these links to bring the swash down a little bit so the washout block isn't working, and I'll go back and forth between these two until I get it right. Okay, I'm going to go ahead and make those adjustments, and I'll be right back. Okay, we're back. Now, what you didn't see off video was I shortened these up to bring the arms up, shortened these up, and when I got back I found I was still having things not lined up, so I wound up lengthening these a turn and lengthening these a turn. Anyway, like I said, it's between these two links, or the servo to the swash links, and the two links, there's two of them, one on each side of the seesaw. Between these two and adjusting back and forth, we finally got to where we needed to be. Now, one thing that is important is that these two links on the seesaw here, you know, this one and this one, are the same length. We don't want these different lengths back here. So there's from each washout arm up to the seesaw, those lengths be the same. Okay. So now we have our swash plate level by adjusting these links. And as you see, I go full collective, and my washout block is just barely, it's not touching the head, but it's almost touching the head. And at full negative, we don't have swash interactions down here on the collar. Okay, so that's what we wanted to achieve. And if you look at center stick, these washout arms are now straight across. So center throttle stick, these arms are now straight across. So basically, we have finished our swash leveling and getting these washout arms set. The next step we'll cover is at center stick, getting these seesaw mixer arms level. That will be these longer links here, and then once these are level, we will adjust these links to get the blade grips at 0 pitch. So center stick, this is level, these arms are level, the mixer arms in the head here are level, and the blade grips are at 0 pitch. Once we get that finished, then we'll go in and talk about getting rid of CCPM interactions at full positive and full negative. And we'll use the ATVs for that. Okay? So with that, on the next step, I'm going to go ahead at center stick, and I'm now going to shorten these links. As you can see, this arm is not level. What you want to see is with the seesaw level with the bird, or the fly bar level with the bird, these mixer arms need to be level with the fly bar cage. Okay, so I'm going to go ahead and shorten these links and get those arms level, and we'll go to the next step. Okay, we're back, and again, going over this, our swash plate's level, we are at center throttle stick, the washout arms are now even with each other, and now we've adjusted these longer links up to the mixer arms in the seesaw so that at center stick, those arms are level with the fly bar cage. Now, it's important that the fly bar is level with the bird. As you see, if you tip it, the interaction, it's not one-to-one. So fly bar level with the bird, with the heli, wash out, and now mixer arms are level. Now, if you'll notice, the blade grips aren't quite at 0 pitch, so we're going to go ahead and shorten these links to get these as close to 0 pitch as we can. Later, we'll do fine adjustments on these with our pitch gauge to get the proper pitch, but the next step I'll do is just go ahead and shorten those, and we'll be at 0 pitch, and basically we've got our head all set up. So I'm going to go ahead and shorten those, and when I come back, then we'll talk about getting rid of CCPM interactions. Alright? Okay, we're back, and we're going to now look for CCPM interactions. So what are CCPM interactions? Well, CCPM interactions happen because not all servos move the same amount from one end to the other, and they also may not move the same linear, in between. So at center stick, since we have all our servos center and we've got all our links adjusted right, we should be at a point where our paddles are level as well. Also, when you put the paddles on, I covered this in another step, but basically when I put the paddles on, I just eyeball them with the fly bar cage, and as you can see, those paddles are level with the fly bar cage. Same with this paddle, level with the fly bar cage. Okay, now you can buy aftermarket devices that clamp on the paddles, and you can bubble level, assuming all your links are right, and get them both the same. But I just eyeball them to the cage. Okay, so with that, let's take a look and see if we can find CCPM interactions. Now, this is what I call Bob's cheapo bubble level. It's basically just a bubble level from hardware store with a piece of double-sided tape, and I've stuck it on the paddle, so it's center stick. Right now we're at center stick, all servos level, we get the bubble level. Now what we want to do is we want to go full positive and see, by the way, I find looking for CCPM interactions much easier on the paddles than on the swash plate. You may not even see the interaction on the swash plate, but because all these links amplify movement all the way up, the paddles are super sensitive, and you can clearly see CCPM interactions in the paddles much easier than the swash plate. Okay, so I'm going to go full pitch. And as you can see, we got a slight interaction. The bubble walked a little forward. We'll go back to center stick, and we're back to level. So we've got an interaction there. So what does that mean? The trailing edge of this paddle is moving down. That means there's a little bit of elevator interaction. So how do we fix that? Well, you may have to play around quite a bit with the different servos to get it right. Right now, we're checking the paddle in relation to elevator in the swash plate. Once we get rid of this interaction, we'll rotate the fly bar and check it in the aileron direction. So what we're going to do is we're going to go into the radio, and we're going to go into our endpoint adjustment. If I can find it. Okay, so we're going into our endpoint adjustment on the radio, into endpoints. So we go into the endpoint, and we go to the elevator channel. There's elevator, channel 2 in Futaba. And what we're going to do is, watching our bubble level, I'm going to bring down the endpoint adjustment until that bubble is level. As you see, the bubble is now level. And basically, I brought the endpoint down to about 92. So if I go back to center stick, okay, there we have a level bubble. Go full positive. Whoops, went a little too far. Okay. Full positive. Bear with. Got to play with that endpoint a little bit. Might have to move the servos up and down a little bit. So we go back to center. We're level. We go full stick collective. A little bit more endpoint there. Back to center stick. Full stick. And our bubbles staying level. Now we do the same from center stick and go negative on the pitch. So when I go full negative, up, we have an interaction there as well. So looks like I have to increase my endpoint for low stick and get the bubble level. So now my endpoint's about 110. So there's full negative. Back to center stick, we're level. Full positive, we're level. Back to center stick, full negative. And you want to do this a few times till you get it right. Okay, center stick, full positive, center stick, full negative. Oh, took out too much. Okay, full negative, center stick, full positive, bubbles level. Center stick, full negative. Yeah, it's a playing around game. I told you these paddles are sensitive. Full negative, bubble is level. Center stick, bubble is level. Full positive, bubble is level. That's it. We've now checked our aileron, our elevator, and we've set our elevator sub trim so that we're level throughout the range. Now what we're going to do is we're going to turn the bird. And we're going to check we're going to check it in the direction of aileron. So there we go. We're center stick. Center stick. Actually, looks like I'm going to have to apply some trim as my swash isn't quite level. There we go. So I just used regular trim so that it's center stick. My paddles are level. Okay, go full positive, and we have an interaction. So now I'm going to go into the endpoint for the aileron, and we're going to adjust those endpoints. Okay, so it looks like my paddle went up a little bit. I'm going to center it. Okay, had to increase the endpoint in aileron. Come down. Full negative, we're at center. Center stick. And we're okay at center stick. Full positive, we're okay. Okay. So that's basically it. Now, one thing you'll notice is watch through the entire range. Now this is just endpoint adjustment. But as you'll see through the entire range, I'm getting some interaction. Okay? And what that interaction is that's because each servo doesn't move as linear through the entire endpoint range. We've just done the endpoints, and we've done center stick. But as you can see, the bubble's walking all over the place in between the ends and center stick. See, at center stick we're okay, full positive we're okay, full negative we're okay, but we're getting interactions in between. Now, I have never been able to completely eliminate CCPM interactions throughout the range with non-digital servos. But you can do it by setting up P mixes. I'm not going to go into it in this video as it's very complicated, but you can go in and set programmable mixes to actually mix out the rest of the interactions throughout the range. But again, I'm not going to go through that in this video. Personally, for a T-Rex, getting the full and the center, so they're all the same, is what I consider good enough for flying. If you wanted to spend the trouble to get rid of it throughout the range of the stick, go ahead with P mixes. But again, it would take a lot to cover that here. Okay, so that's looking for CCPM interactions. That's the way I like to do it. So basically, we are done now. We've got all our servos set up. We've got our head set up. All our arms are level at center stick. We've adjusted the endpoints for interactions on both the low pitch and the high pitch. And basically, that's it. We are done with the top of the head. All we have to do now is put our blades on, and at center stick, go ahead and get the blades at 0 pitch, and we'll check our ends. And that's where we'll go into the radio swash, because we may have to increase or decrease how much the pitch is. We may have too much or too little. And of course, if we do that and we have to increase this throw, we may have to again go in and move our swash plate down if our head block's hitting. So I'll cover that in the next step. Okay, we're to the last part of setting up the head, and that is checking the pitch of the blades. So the first step is center on the throttle stick again. We want to adjust these links here that go up to the blade grips so that our pitch gauge reads 0. Now here's how I use a pitch gauge. I set it to 0, I lock the nut. What you do is you eyeball now the fly bar. It's important that the fly bar is level here, because as you can see, if it's not, the pitch gauge won't read the same. So the fly bar is level. What I've done since I can video this is I've taken one of the aligned plastic blades and cut it off so it isn't sticking in the camera. But the idea is to show you the principles here. Anyway, so center stick, we've got our gauge at 0, and you eyeball the top of the pitch gauge with the level fly bar. Okay, what we want to check for is 0 pitch. If we don't have 0 pitch, we adjust the link on the blade grip so that at center stick we have 0 pitch when the fly bar is level. Okay, now what we want to do is we want to check our pitch range, whether we have too much or too little. Now, as you recall in the radio setup, I left the swash 50% swash mix on the pitch mix. That's because usually at 50% on most radios, you'll have too much pitch, and that'll allow us to adjust it down. If we had it set too low when we were doing all our adjustments here to make sure our washout block didn't hit the head and our full pitch range, then what would happen is you wouldn't have enough pitch. You'd have to increase that mix, and now chances are your washout block will start striking the head. So it was good to make sure we get as much pitch range and all this mechanical stuff as possible first, and then go in and reduce it to get the proper pitch. And that's what you'll see here. So now I'm going to go full positive pitch. Okay, so then you loosen up the nut on the pitch gauge, and we try to find out how much pitch we have. And as you'll see, I bring the gauge way up here, and I'm up over at 12 at the max of the gauge, so I'm up at 12 degrees, as you can see, with the fly bar level, and we eye the top of the gauge again with the fly bar. That's what we're getting. We're getting 12 degrees of pitch. And if I go full negative the other way and slide the pitch gauge the other way, you're seeing that we're now getting 12 degrees negative. Now that's too much pitch in my opinion. I personally like to set up for 11 myself. Some people probably set up 10. If you set up for 11, you got to watch your collective management, because you can bog out the bird if you give too much pitch and cyclic at the same time. I like 11. So how do we reduce that? Well, what we do is we go into the radio menus, and we go ahead into the swash menu. Okay, there's the swash menu. We go in there, and we go down to our pitch setting. There's pitch, and we reduce that %. So you go ahead and reduce that % until your pitch gauge at maximum pitch. I'm going to go ahead and show that now. Until your pitch gauge reads 11. So I'm going to set the pitch gauge to 11. Okay. And tighten it up. And then we're going to check our pitch. So here we go. Now I've reduced it a little, and there we go. We're at full negative, and we've got 11. I basically reduced the pitch in the swash menu. I basically removed the pitch percent to about 42. Okay, now if we had all our arms level and all our links right, when we go the other direction, and we had the blades at 0 at center stick, we should read 11 as well. So I'm going to set the gauge to 11. We're going to go ahead and check, and sure as heck, there we have it. We have 11 degrees of pitch with the fly bar level. And so we've got same amount of pitch both ends, center stick is 0, and we're good to go. Now, if you find that you're getting more pitch in one direction than the other, then you didn't do something right adjusting all the links in the head. You're getting, the arms aren't level, and you're getting an interaction because the bell cranks are moving more to one side than the other. So go back and recheck all your adjustments here so that you get the same amount of pitch, top and bottom, and at center stick you're 0. Okay, so that's basically setting up the pitch. Okay, last step. How much swash cyclic do we want in aileron and elevator? Now, the proper way, the one way to do this, or the correct way to do this, is to use your pitch gauge again. I'm not going to show it because I showed you how to use the pitch gauge setting the pitch. But the idea being you want as much cyclic movement here that the pitch gauge deflects a maximum of 6 degrees. Okay, so 6 degrees in one direction, 6 degrees in the other direction. And that's the way you want to set it up. You can actually dial in more or dial in less depending on how quick you want your bird to react in cyclic. Going over 6 can get you in trouble because think about it. If we're at full positive pitch, we've got 11 degrees, and we go full cyclic at 11 plus the 6, you're now at 16. If we were to set those at 8, you're now at 18. Now, believe it or not, I like to set up that way. I like to set for about 8 degrees of pitch, so I've got a nice quick bird. It's just you got to remember collective management and cyclic management when you're flying and doing 3D, that you don't bog the bird down by jamming in, you know, a bunch of pitch and a bunch of cyclic. Okay, so for a new person, this is a general rule of thumb if you don't want to use a pitch gauge. For a new person, someone new, I like to set up the amount of swash so that if you look at the swash plate, there's a rubber ring, and then the ball that's on the main shaft has a flat spot in the ball. What I do is make it so the swash plate deflects just to where that rubber O-ring meets the flat spot of the ball, and that gives a very tame cyclic for a new person. For myself, I like to get almost as much as I can get. Again, probably running about 8 degrees in the pitch. So how do you set how much throw you get? Well, once again, we don't mess around with endpoints. We don't mess around with ATVs. We go into the menus, and we go to the swash menu again. Okay, and we go into the swash, and the way we control how much throw for aileron and elevators by changing this percent. Reducing this number will reduce the amount of throw. Increasing this number will increase the amount of throw. Okay, so again, I'll dial in more myself, so I'll probably wind up at around 60% for aileron and 60% for elevator. That's basically where I like it. It's where I like to fly. But again, that's a preference for the user. You can slow it down or speed it up. But again, a general rule of thumb is 6 degrees of pitch in one direction of the aileron, 6 degrees in the other direction of the aileron, and then do the same thing for elevator. Okay? So that's it. Basically, we are now done setting up our servos, setting up getting everything level, getting the pitch correct, and then setting up the amount of cyclic throw. And basically, we are done, and we're ready to continue putting the rest of the bird together. I hope this video helped you out, and enjoy.